Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question, all passes from source to target. Given a directed acyclic graph diag of n nodes labeled from 0 to n-1, find all possible paths from node 0 to node n-1 and return them in any order. The graph is given as follows. Graph I is a list of all nodes you can visit from node I. Which means there is a directed edge from node I to node graph ij. So for the example 1, the graph is like 1, 2, 3, 3. So what does that mean? So 1, 2 means that from node 0, you can go to node 1 and node 2. And then at the index 1, the list is 3, which means from node 1, you can go to node 3. And then the next element is also list of 3, which means from node 2 you can go to node 3. And then the last element is actually empty, which means, okay, from node 3 there is no outgoing edges. So in this case, from the node 0 to node n-1, which is 3 in this case, there are two possible paths. One is 0, 1, 3. The other one is 0, 2, 3. For the example 2, so in this graph, node 0 can go to node 4, node 3, and node 1. Node 1 can go to node 3, node 2, and node 4. So node 2 can go to node 3. Node 3 can go to node 4. And node 4, there is no outgoing edges. How many possible passes you can go from node 0 to node 4? One is from 0 to 4 directly. The other one is 0, 3, 4. Another one is 0, 1, and then 3, 4. And then the next one is 0, 1, 2, 3, 4. And then the next one is 0, 1, and then 4. So those are all the possible passes. So how to solve this one? So the idea for solving this one is using the depth first search. Let's say I'm currently at node I. Suppose I already visit node I. And then I'm trying to visit the next node. So from node I check the next node I can visit, and then add that to the path. What is the stopping condition? As long as I reach the node n-1, then I know, okay, I find a valid path, then I add that path to the results. So let's start coding. So n equals the length of graph, the total number of nodes, and then you use a result to keep track of the results of the possible paths. And then define the DFS I. So we are currently at node I. And then we have a path. So the current path that's starting from node 0 to node I. And then if this I equals to n-1, so we reach the destination. In that case, we append the path to the result and then we just return. If not, if we haven't reached the destination node n-1 yet, then let's check for the next node in graph I. We call DFS for next node, add this next node to the path. And then here we just call DFS 0, starting from the node 0, and then our path already contains 0. Then we just return result